Hello and welcome to the topic copying lists in Python. Let's take an example of a complex list. Let's say L1 equal to first element is an integer 10, second element is 2.5, a float, third element is a list, let's say 1, 2, and 3, and maybe fourth element, a string Python. This list has 4 elements in this. It has a nested list as well as an element as we see here. If you want to copy this list, you can use the copy function or copy method of the list data type. So L2 equal to L1 dot copy. So when you do L1 dot copy, L1's copy is created and it gets stored in the variable called L2. When we do this, the same elements as L1 gets copied in L2, provided that the memory address of L1 and L2 are different. How can we verify that? We can use the is operator to check the memory addresses or the identities or the IDs of the L1 and L2 list. If it gives true, the memory addresses are same. If it gets false, memory addresses are different. So in false means the memory addresses are different for both L1 and L2. Now, let's do one thing. Let's try to change the first element of L2. So L2 of 0, I'm changing it to, let's say 1. The current value is 10. I'm changing it to 1. This is how we change the first element of L2. When we check the value of L2, it obviously gets changed. But what happens to the value of L1? Will the first element of L1 change? Since the memory addresses of L1 and L2 are different, it should not change. It has not changed because the memory addresses are different. Now let's take another example wherein I will try to change the last element of the inner list of list L2. Right? So when I do that, so L2 of 2. Why 2? Because this is 0th element, first element, and second element. L2 of 2 of the last element, which is -1, I can take. And let's say I want to change it to 0. So when I do that, this 3 gets changed to 0. Right? Now, the question is, will this change reflect on L1? Let's check. What happens here? It actually gets changed. Why? When we change the first element of L2, it was not reflecting in L1. But when we change the element of the inner list of L2, it gets reflected in L1. Even though the memory addresses of both L1 and L2 are different. Why this is happening? Let's understand. So when we created the list L1, let's say the values were 10, 2.5, 1, 2, and 3. And the last element was Python. Let's say the memory address of this list is 1, 2, 3. Random address I'm taking. When we did L2 equal to L1 dot copy, in this case, what happens? L2 is created on a new memory location, let's say 4, 5, 6, with the same elements, right? The elements, the values will be same. But the memory addresses of both L1 and L2 are different. But what happens is the element memory addresses, the memory addresses or the references of the inner elements of the list are shared, which means, let's say if the memory address of this list is 999, the memory address of this list also will be 999. So when we use the copy function, it does not do a copy of inner elements. It just do the copy of the list. This is called shallow copy in Python. And that's why when we change L2 of 2 of -1, which is this element, to let's say 0, we are changing the list at the memory address 999, which means this list will also get affected, right? Because this is the same list as this. So this also gets reflected. And when we check the value of L1 of 2 of -1, we get 0 here as well. Since there is no recursive copy happening in shallow copy, or this copy, this is called shallow copy. Now, this could be a problem in cases wherein you want to have a list, original list with you, and you want to create a copy L2 of that list, and you want to modify L2, but the original list has to be intact without any changes. In this scenario, shallow copy will not work, right? So there is another type of copy which is called deep copy, which we'll see, which will solve this problem of shallow copy of not copying the elements recursively. Before we jump into that, there is another way to create a shallow copy. Apart from using the copy method of the list, we can make use of another way of shallow copy is to use copy function of copy module. So there's a module called copy that we will import. And there is a function called copy. Let's say, for example, if you want to create L3, which is a shallow copy of L1 again, so we'll have to use copy module dot copy function of L1. In this case, again, L3 also is a shallow copy of L1. Again, if we change L3 of second element of, let's say, -1, which is again the same element, to, let's say, 100, obviously L3 will get changed. Also, it will get reflected in L1 as well, because again, this is a shallow copy. So there are two ways of creating shallow copy. Copy method of the list data type, also copy function of the copy module. Now let's jump to understand deep copy. What is deep copy? As I said, deep copy will do the recursive copy of the inner elements of the list as well. For example, now again, how to do a deep copy? Using the deep copy function of the copy module. So the copy module has two functions, one copy for shallow copy, one deep copy for deep copy. So we don't have to import it again because we have already imported. So we'll just make use of copy dot deep copy of, let's say, L1 again, and we'll store that copy in L4 list, right? The value of L4 is exactly same as L1 at this moment. Obviously, the IDs of L1 and L4 will be different because it's a copy and it's a deep copy, which means the IDs or the memory addresses of this inner list also will be different. Let's verify that. L1 of 2 is L4 of 2 will not give us true. It will give us false. But when we do the same thing for the shallow copy, L2 of 2 is L4 of, sorry, L1 of 2 is L3 of 2, we'll get a true. The inner list has the same memory address. Now, this is L4. If we try to change the inner lists, let's say first element from 1 to, let's say, -1. L2 of L4 of 2 of 0 equal to -1. Now, L4 inner list first element will get changed, but since L4 is a deep copy of L1 and the inner elements were recursively copied separately on separate memory locations, it will not have any impact on L1. This is what deep copy is. To summarize, shallow copy creates a new list at different memory location, but the inner elements of the list does not get or do not get copied. If any changes are done to the copied list, it will get reflected in the original list. Means if you do any changes in the nested element, it will get reflected in the original list. How to implement or how to create shallow copy? There are two methods. We have already discussed that. Deep copy does a recursive copy. It will copy the inner elements or the nested elements as well. If any changes are made to the nested element of the copied list, there will be no change in the original list. How to implement it? using the deep copy function of the copy module. That's all for the video. Thank you.